Hello everyone. We are AI Challenger. We are in this Accelerator course. We are tasked with the Parkinson cognitive task using the AI teachable machine. Next slide. We have 6 members, TV, Kevin, and Tia from Myanmar, and Jason from Indonesia, Gary from Singapore, and George from India. Next slide. I would like to invite Gary to present next slide.
Thank you, Kevin. Giving everybody in context to the project. So Parkinson's disease diagnosis can be challenging and often relies on subjective assessments. Our AI-powered tool could serve as a valuable first-line screening mechanism, prompting further medical evaluation for at-risk patients. Next slide. Our problem statement uses the 4W framework. So we look at people who are over 60 of age, healthcare workers, researchers, health educators working on Parkinson. And then we look at non-intrusive cognitive tests for early detection and management of Parkinson's disease. Where will we do it? We'll be at free health screenings at family events, health facilities, mental health roadshows, and community gatherings. The reason is Parkinson Roadshow for over 60 with free screening, counseling will create awareness and education in early detection to better management of symptoms. Next slide, I will invite Jason to continue the presentation.
Okay, thanks, Gary. So for the solution, we're using computer vision to do the prediction task. We're using teachable machine environment to create 3 trained image classification model, each for clock, spiral, and wave drawings. The model is a binary classification model, so the result of the detection will either be healthy or Parkinson's disease. We're using Python to load the 3 models together, make interpretations from them, and deploy it in a web application using Streamlit. Next, I would like to invite Tiha to continue the presentation.
Thank you, Jason. Next, I would like to explain a bit about the data sources we've used to train the models, the 3 models, and how and where we have collected that data. So to train the models, we have done an extensive research of the and collected the data images from existing AI models, medical research data, and publications. So the team have also tried to obtain data from hospitals, but sadly we couldn't obtain these data in time. So in terms of cleaning the data, so we have made sure that all the images that we import into the training have similarities in terms of how they are made. So for example, all the data we have imported are drawn with a black pen and on a white background paper. So we make sure that this because there might be less confusion by the models. We've also put all of the resources we use to obtain the data in the next slides. So back to you, Jason, for the evaluation.
Okay, thanks, Tiha. So for the model itself, each model we split the data set into 80 and 20 ratio. The 80% of the data set will be used for training by feeding the images into the teachable machine environment, while the 20% of the model will be used for testing. The result of this learning process is first the trained model itself, second is the confusion matrix, and third is the F1 score, which is the harmonic mean between the precision and recall. We're using these 2 metrics, the confusion matrix and F1 score, to evaluate the accuracy of our model and also review any errors or anomalies during the test phase. Next, I would like to continue to invite Kevin to continue the presentation.
Thank you, Jason. I would like to brief about our project step by step. The first, we have to develop 3 teachable machine model, including the clock, wave, and spiral set by Jason. Next slide, please. And then we get a H5 file of the teachable assistant and deploy it into the Streamlit using GitHub. Next slide, please. These are the screenshot of our final project, and in the detail of our demonstration step by step will be done by our chief software engineer, Thierry. Thank you all.
Thanks, everyone. So we will continue with the demonstration of our models next.